Hello everyone, this is Ketish here. In this video, I'm going through the AQA Combined Science Physics Paper 2 Higher Tier from 2025. Question number 6 is on the topic of forces. A triathlon race consists of swimming, cycling and running. One athlete in a triathlon swims at a speed of 1.5 meters per second. How does the athlete's swimming speed compare with the typical speed of a person walking? Now, if the swimming speed is 1.5 meters per second, the walking speed is roughly about the same, 1.5. Okay? So that should be equal. Figure 8 shows a speed time graph for the athlete for the whole triathlon. So you have during swimming, it's 1.5 meters per second. At 500 seconds, cycling begins. So he's starting at 7.5 meters per second. And at the end, which is at 1,800, 800, 900, 1,758 is 1,900, sorry, 1,900 seconds. The speed has gone to 6.2 meters per second. Now this small line which is straight here, that's for about 100 seconds. That's 4 meters per second. And then at 2000, it goes from 4 seconds to 2.2 meters per second. So it's actually decreasing the speed or decelerating. So let's have a look at the question. Now it's always best to interpret the graph like this before you start, because I bet most of these numbers that I've written down over here, we are going to be using it later on. So it's better to spend a little bit of time interpreting the graph before we read the question. The cycling part of the race was on a straight road. The work done, so the work done by the forward force was 110,000 joules. Remember, work done, if you look at the physics equation sheet, is equal to the force multiplied by the distance moved in the direction of the force. Calculate the mean force, forward force. Now, if I want to calculate the mean forward force, which is this, I would need to work out the distance moved. That's why it's a 6-mark question. It's actually asking you to use 2 equations, right? So in order to work out the distance, I need the work done is already given, which is 110,000 joules. I need to know the distance. How do you work out the distance? Well, I've got a speed time graph, right? The cycling part of the race was on a straight road. So let's have a look at the cycling part. The cycling part is basically this area, right? So the speed at the start is 7.5 meters per second and it ends at 6.2. I can work out the average speed, right? And use the time that is given here. Since speed equals distance divided by the time, I could rearrange the equation distance equals speed multiplied by the time. I can use this equation to work out the distance. So let's do that. So how long did it actually take? We need the time as well. So we are starting at 500 seconds and that's 1900 seconds. So from there to there, 1900 minus 500 is equal to 1400 seconds. So time taken is 1400 seconds. The mean or average speed, let's say the mean speed is equal to 7.5 minus 6.2. I'll have to divide this by 2 to find out the average speed, which is 6.85. I'm not literally working out the difference in the speed, I'm working out the mean speed. So I've got two values here. Oh, should be plus in order to work out the mean speed, not take away. Sorry, that's 6.85 meters per second. So using that, I can use the equation distance traveled is going to be the speed multiplied by the time, which is 6.85 multiplied by 1400. That would give me 9590 meters. So that should give me at least 3 marks. So I worked out the time 1 mark, the speed, and the distance, the 3 marks. So let's get the next 3 marks. Work done equals the force multiplied by the distance moved. The work done was 110,000 joules multiplied by the force multiplied by the distance, which is 9590. Rearranging it, force equals the work done divided by the distance moved, which is 110,000 divided by 9,590. That gives me 11.470 newtons. So again, the other marks is coming from these 3 points. So 1 mark for substituting the equation, 1 mark for rearranging, 1 mark for the correct answer. They're not asking you to give the answer in any form of significant figures, so you can just leave the answer as it is. So the mean forward force is 11.470 newtons. Figure 8 is repeated below. The first part of the run was on a circular track. Now, where is the running beginning? The running section is here. The first part of the run is actually this section. Right? See that flat line? And that's the first part. And the time taken for the athlete to run the track was 100 seconds. So from there to there, remember we had 1900 there. So that's the 100 seconds there. First part of the running. Now the question is asking, describe the velocity of the athlete during the first 100 seconds of the run. So now it's a flat line. That means the speed was 4 meters per second. Since it's a flat line, it should be constant speed, right? Well, describe the velocity of the athlete during the first 100 seconds of the run. Now, velocity is a vector quantity. Now, if it's a vector quantity, the magnitude and direction matters, because vector quantities have size, magnitude and direction, or size and direction. So how do you describe the velocity? Magnitude of velocity is constant, or you could say the speed is constant. What about the direction? Direction of velocity is changing, because it's going around in a circular track. After running around the track once, the rest of the race was on a straight horizontal road. Explain how figure 8 shows that the magnitude of the direction of the athlete increased. So not the magnitude of the deceleration, not direction. Deceleration. Deceleration is when the speed is going down, is actually increasing. That's a play of words. Okay. So let's have a look at the diagram again. So from this point to here is decelerating, the speed is going down. Now, if it was a straight line between these 2 points, then it would be constant deceleration. Now, here you can see it slowly, and then it's actually sharp here. Now, if I was to find the gradient at this point, it will be less than the gradient at this point. So now, why am I talking about the gradient? Because it's a speed time graph, right? Y over x is the gradient, which is speed divided by the time would be the deceleration, right? So the gradient is actually going down, so the deceleration is increasing. That is our answer. So the gradient is equal to the deceleration right? The magnitude of the gradient or deceleration increased. There you go. That brings us to the end of this question and to the end of the paper. Thanks for watching. If you found this useful, always click the subscribe button and the notification icon, so that when I discuss and upload more papers, you'll find this useful for your GCSE exams. Thanks for watching. This is Ketish here again. I will see you in the next video.